Welcome to Dynamic Coaching Center. So we were discussing about the past previous year question papers of Staff Selection Commission JE Mechanical preliminary level. So this is a continuation video. So those who are new to our channel, please to subscribe, and then in the description I would have attached the link for the previous videos about the thermodynamics and other topics, which you can check it out, and that would be of great help when you are preparing for this. So let's get started with the machine design part. So machine design part. So this question happened in the year 2008. So lap and butt weld may be used on materials up to approximately. So you have been given with four options. Option A 25 mm thickness, option B 40 mm thickness, option C 50 mm thickness, and option D 70 mm thickness. So lap joint, in the sense, you might know that if you have a plate and on that plate itself another plate would have been kept, okay, but in the sense it would be kept in this fashion, and then the weld would have been done here. So both lap and butt welds may be used on the materials. To what amount of thickness was the exact question which has been asked. So basically they are actually used in the materials up to maximum of 25 mm thickness, not more than that. So if you get to the option A would be the correct answer. So let's move on to the next question. So the thickness of the boiler plate is 16 mm. So, and the diameter of the rivet which is used in the boiler joint is. So you have been given with four options. Option A 28 mm, option B 10 mm, option C 20 mm, and option D 24 mm. Question was asked in the year 2012. Okay, so this is a numerical thing which you can do it approximately. So you have something called when you consider the thickness of the boiler. So thickness of boiler plate is given as 16 mm in the question, and they are asking you to find out the diameter of rivet which is being used. So you have got Unwin's formula to find out the diameter of the rivet, which is 6 root t, where this t represents the thickness of the boiler plate. So it would be 6 root 16. So it's a simple numerical thing. So 6 into 4, so it should be 24 mm. So if we just get back to the options, option D would be the correct answer, 24 mm. So let's move on to the next question. So the shear strength, tensile strength, and compressive strength. So basically these are all the three stresses which are acting on a riveted joint. So they have given the shear strength, tensile strength, and compressive strength in terms of load value for a rivet joint as 100 Newton, 120 Newton, and 150 Newton respectively. If the strength of the unriveted plate is set as 200 Newton, then what would be the efficiency of the riveted joint? So you have been given with four options. Option A 75%, option B 80%, option C 50%, and option D 60%. And this question was been asked in the year 2012. Okay, the same year. So we have been given with the shear strength value. So shear strength is given as 100 Newton, and tensile strength value is been given as 120 Newton, and then compressive or crushing strength value has been given as 150 Newton, and they have also given the strength of unriveted plate. So the unriveted plate strength is given as 200 Newton. So we need to find out the efficiency of the joint. So efficiency of the joint takes this formula, that what is the minimum strength, and what is the strength of unriveted plate. Okay, so the minimum strength out of these three is 100, which is for shear. So it is 100 divided by strength of the unriveted is 200. So it is 0.5. If you convert that into percentage, it would be 50 percentage. So if you just get back to the options, option C would be the correct answer. So we'll move on to the next question. So this is related to a screw. For a screw, the angle of helix alpha is related to the lead L and the mean screw thread diameter D as. So what is the relationship between the angle of helix alpha and lead value L and the mean screw thread diameter D? So you have been given with four options. Option A, tan alpha equal to L by D. Option B, tan alpha equal to D by L. And option C, tan alpha equal to L by pi D. And option D, tan alpha equal to pi D by L. Okay. So this question was been asked in the year 2013. Okay. So I'll give you an example. Suppose if you have a screw thread jockey. Okay. So imagine that this is the handle of it and this is the diameter. Now, if you say the distance between two consecutive threads as pitch, now if I rotate this handle for one full circle, then one thread will move upward, right? If I rotate in one clockwise direction, if I rotate in the anti-clockwise, it will come down by one thread, right? So in this fashion, I can relate this and remember that as tan alpha equal to lead value by pi d. Okay, so pi d, because it is a circular one. Okay, so you have to remember that. So if you get back to the options, option C would be the correct answer, tan alpha equal to L by pi d. Let's move on to the next question. So the shearing strength of the rivet is 50 Newton per mm square. If the diameter of the rivet is doubled, then what happens to the shearing strength? You have been given with four options. Option A, 100 Newton per mm square. Option B, 200 Newton per mm square. Option C, 50 Newton per mm square. And option D, 300 Newton per mm square. And this question was asked in the year SSC JE 2014, set 1. Okay. Now, so the ultimate thing is shearing strength. Last time the question was being related as shearing strength in terms of load value, but this time it is being related to the stress value. Shearing strength value is being given as 50 Newton per mm square, and the question asked is that if the diameter of the rivet is double, then what happened to the shearing strength? So shearing strength in terms of stress is being given in the question. It is actually a material property. So it doesn't change. Okay, so I can say that it remains same. So option C would be the correct answer. Let's move on to the next question. So this question was also asked in the same year 2014, but for set 2, the rivets are generally specified by, you know that any product or whatever be the component, it will be generally specified using certain terms. Like rivets are generally specified by, you have been given with four options. Option A, diameter of the head. Option B, thickness of the plates to be riveted. Option C, length of the rivet. Option D, nominal diameter. See, rivets, or if you just if you are using some design data book and anything, you might have come to know that rivets are generally specified by its shank diameter, which is same as that of nominal diameter. So if you get back to the options, option D would be the correct answer. So let's move on to the next question. So this question was being asked in the year 2017, set 1. The shock absorbing capacity of the bolt can be increased by. Till now we have been seeing about the rivets. Now this time the question was related to bolt. Okay. The shock absorbing capacity of the bolt can be increased by. You have been given with four options. Option A, it is tightening it property, and option B, it is increasing the shank diameter, and option C, grinding the shank, and option D, using washer. See, basically, if the shank portion of bolt is slightly turned down, if it is turned down to a diameter of equal or even lesser than core diameter. So bolt would have the core diameter, right? So if you make the shank of the bolt to turn down its value of diameter either equal to or slightly even lesser than the core diameter of thread, then the shank will actually undergo higher stress. The stress will be more. This means that the shank will absorb large portion of energy, thus relieving the material at the sections near the thread. So I can say that it's not good thing. So instead you can go for grinding the shank to a little amount. So I can say that yes, the shank diameter, if you just pull it down, it should not increase. It should not be increased because you have been given with an option of increasing the shank diameter, which is wrong. Grinding the shank diameter will actually make it little bit reduce or equal to the core diameter of the thread, which actually helps in absorbing maximum amount of stress. So that would be the correct answer for shock absorbing capacity. So I can say that option C would be the correct answer. Let's move on to the next question. This question was been asked in the year 2017 set 1. Which one of the following is a trapezoidal thread? You have been given with four options. Option A, acme, option B, square, option C, buttress, and option D, all the options are correct. Actually, trapezoidal thread, this trapezoidal thread is a acme thread, whereas this square, buttress, these two are actually modifications to square thread. So I can say that option A would be the correct answer. Trapezoidal thread is an acme thread. So we'll move on to the next question. So this question was being asked in the year 2017 set 1. The efficiency of self-locking screw. So already I would have explained about this screw thread jockey, right? So this is actually a self-locking one. So if you just rotate clockwise once, then one thread moves upwards, which means whatever load which is kept on it would have raised by a certain distance linearly. But if you remove the hand from the handle, it is a self-locking one. It stays at that position. It remains at that position. It doesn't come down. To make it come down, you have to rotate in the opposite way, right? So they are asking question as the efficiency of the self-locking screw is what, by how much? Option A more than 50 percentage, option B less than 50 percentage, option C equal to 50 percentage, and option D none of this. See, generally the efficiency of the self-locking screw is actually lesser than 50 percentage. You can't say exactly equal or even more than. More than is not at all possible, but you can say that somewhere, so it is lesser than 50 percentage. So option B would be the correct answer. So let's move on to the next question. So the rivet head for general purpose is being shown in the diagram. So this is a rivet head which has been given, and you have been given to identify what type it belongs to. Option A snap, option B pan, option C countersunk, and option D flat. So if you have worked in certain softwares like SolidWorks or CATIA also, you might have known this. So basically you can see that this portion, it has been reduced from the original of this much. So I can say that this rivet belongs to countersunk head. It is sinking, right? It is reducing. So I can say that option C would be the correct answer. So let's move on to the next question. So this question has been asked in the same year 2017, but for set 2. Allen bolts. What is Allen bolts? Allen bolts, you have been given with four options. Option A, it is a self-locking bolt. Option B, designed for shock load. Option C, it is used in aircraft application. Option D, it is provided with hexagonal depression in head. See, generally I can say that Allen bolts, this Allen bolts are generally provided with hexagonal depression. So there will be some depression, but that is hexagonal in its head. So I can say that option D would be the correct answer. So we'll move on to the next question. For tight leakage joints, the following type of thread is best suited. Option A, metric. Option B, buttress. Option C, NPT, National Pipe Threads. And option D, Acme. So this question was also asked in the same year 2017 set 2. So actually something related to pipes. So you can see that for tight leakage joints, generally for pipes for carrying a longer distance of fluid, we go for national pipe threads in general to avoid the leakage. So I can say that option C would be the correct answer. So let's move on to the next question. Which of the following pipe joint would be suitable for pipes carrying steam? Option A, flanged. Option B, threaded. Option C, bell and spigot. Option D, expansion. So this question was also asked in the same year 2017 for set 2. Okay. See, generally expansion pipe joints, because you know that it is carrying out steam, right? So expansion pipe joints are actually suitable for pipes particularly carrying steam, because then only it can accommodate expansion as well as contraction with respect to temperatures. So I can say that expansion joints would be best suited for this application of pipes carrying steam. So let's move on to the next question. So till now, if you have watched this video, you might be able to answer this question very easily. A riveted joint may fail due to, you have been given with these three statements and four options. So the first statement is shearing of rivet. Option 2 is shearing of the plate at an edge. Option 3, I mean the statement 3 is crushing of rivet. So you are given with four options. Option A, only one is correct. First statement is correct. Option B, second statement is correct. Option C, third statement is correct. Option D, any of the three statements, 1, 2 or 3. This question was also repeated in the same year 2017 for set 2. A riveted joint actually fails because of all these three conditions. Very, very important. So shearing of rivet is a direct one, crushing of rivet is direct one, and you have to remember this particular point, which is very tricky, shearing of the plate at an edge. So I can say that option B would be the correct answer. So let's move on to the next question. So the distance between the centers of rivets in adjacent rows of zigzag riveted joint is known as. So they are asking you to connect this relation, distance between the centers of two rivets of adjacent zigzag riveted joint. Option A, pitch. Option B, back pitch. Option C, diagonal pitch. Option D, diametric pitch. Okay. So I'll just put a diagram and then you can see. See, basically, if you have rivets like this, of any shape. Now it has been given as zigzag, any pattern. So from this center to this center, let's take a comparison. So from here till here, this pitch is known as back pitch. And from here to here, this distance is actually diagonal pitch. And here to here, straight distance, this distance is nothing but simply P, which is pitch. Okay, so here they said that the distance between the centers of the, in this question they have given the distance between the centers of the rivets in the adjacent rows. Okay, so this is one row and this is the second row. Okay, so the distance between these two centers. So adjacent row in the sense it would be zigzag pattern, it is said. Okay, so which means you have to be careful since it is zigzag in the sense it would be like this, right? So which means I can say that between one row and adjacent row it would be always diagonal. So option C would be the correct answer. Then one more question in the same year, but for set 4 they have asked distance between the centers of the rivets in the adjacent rows of zigzag riveted joint is known as. So it is the same question which has been repeated. So again the option is diagonal pitch. So with this we can conclude this video, and those who are new to this channel, you can subscribe to this channel and hit on the bell icon so that you will get notified with all the other videos whatever we post on it. And we are completely focusing on the classes as well as the previous year past question papers of SSC JE prelims as well as mains. So you can just follow your channel and you can share this video with anyone who is actually preparing for this particular examination. And in the description we have given the link for the previous videos which you can check it out. Thank you.